Hi folks, I'm trying to make a better video here of my system for Swaging 22 long rifle. I hope you guys can see that. It looks washed out on the screen. Wonder why that is. Well, hopefully you can see it all right. This is the press. It's got the swaging die on top and the base swaging die on the bottom. I'll take that apart and show you that towards the end of the video. Now, I have here, this got things full of little cores, which I made a mold to make cores that come out around 41, 42 grains, just a little bigger, a little heavier than the bullet will be. And I also made that core mold so it would drop cores that are around 0.210, 212, 215, something in that area. And that's because if I drop them narrower, I have room to put powder coat on them and then swage them to the final dimensions and the final everything. Now, the way it's set up right now, one of the problems I have is they don't stick in the thing. So I have these pliers, which are, I don't know if you can read that, it says Model E9E. These were specialty pliers that I bought off of eBay that are square jaw pliers. And as most of you probably know, square jaw pliers being in huge demand are very expensive right now. So I bought these, which only opened that far when I first bought them. I had to take them apart and grind out the bases of the jaws with longer slots so they'd open farther. And then I ground this stop area in here a little bit. I left them to where they bottom out a little bit open. I still may make brass or aluminum, different kinds of jaws for this. I have to figure out how to make like a little rail system to hold the jaws. But it works really well the way it is. I paid, I think, $11 for it, $10, $11, so that was real cheap. Okay, so you saw me put one of those cores in there that's been powder coated. Now I'm swaging it, and I tap this to get them out, and it comes out like a 22 bullet, but it's got a little bonnet around it, which is where all the excess lead goes. I pick that off with my fingernail, and then I have a powder coated swaged bullet with a real nice hard surface that doesn't need any wax or lube. I have the base there. I'll show you a better picture of it when I get the close-up lens on there. But anyway, this is the process of making them. I put them in there. That's another small one. These probably are all small, narrow. This is an old batch that I had sitting around, and I may have, since I made these, I'm squeezing it to expand the diameter so they stick in there and they don't fall out. And like I said, this is probably an old batch that I didn't have the mold quite big enough at that point. Made it a little bigger. Now, these dies have to be made to fit exactly. So I'll show you what I got here. This die up on top has got a receiving area for this to receive, to guide it to center. Otherwise, these guys would be off center, and that would be, you know, they wouldn't be any good at all. Yeah, these are all going to be small. So the mold the way I have it now, very few of them are too small. Or I shouldn't say very few, maybe 20-30%. I got to go through and expand those holes again a little bit, make them a little bit bigger, and everything has to match. You know, the core mold has to match, and yada yada. Otherwise, you know, the system won't work. So this is how I do it for now, until I get a way figured out to hold these in here without having to squish them a little bit. And now you notice I'm not using any case lube or anything on there. I do have a lanolin based case lube that I make, that I use from time to time when they're getting stuck. But I've got it now to where when I make the dies, I polish them well enough that nothing sticks. They come right out, as you can see, just a little tap and they pop right out of there. So another thing is, this has got an extraction pin in it, 2 millimeter extraction pin, that bottoms out. It won't go up, so it forms a top for the bullet, for the nose, so you don't get a little squirt of lead going up into the channel of the extraction pin. And I hollowed that end of that pin a little bit to contour to the tip of the bullet. So basically that's it. We have a swaging die. Now this is adjustable. This adjusts the nose pin. If I wanted to screw it in farther, these things would come out as hollow points. I'll show you one. I'll make a hollow point. I don't know how deep that's going to be, but we'll see what happens. Now, it might be hard to get off the pin. There. So there's a hollow point. I twisted it when I pulled it off. Or did it go not in the middle? I think it went not in the middle. That's strange. That is strange. I don't like that. I'm going to try another one. Oh, I know what happened. When I put it in there, it was cockeyed. I'm going to squish this so that nose does not hit the base pin, the extraction pin. That way it'll hit center, or it should. Now there's other ways of making hollow points. I don't make hollow points. I don't need them. There's no reason for me to make them. Yeah, there's a better one you can see. And so this is going to be, however amount that hollow point displaced, that won't be a 40 grain bullet. That'll be a little less. And, you know, if I wanted to make hollow points, I'd dial it in, make them bigger or whatever. This is the way it is. Okay, that's the way it works. Now, I'm going to take it apart, and I'm going to put the lens on the I'm going to put the lens on the camera, close-up lens. Well, this will probably come out in 2 pieces, because it is 2 pieces. And I wanted to do that to show you how it works. takes a while to unscrew. Okay, there's the top with the extraction pin. Alright, now, I do have a little bit stuck in there. That's unusual. This is very, that would have come out, but I don't like it when there's a channel in there. I suppose I could leave that in and show you with the lens. Putting the lens on here. And I'm going to bring this down so it's easy for me to show you what's going on. Alright, this is the die. I get some better light on the inside for you here. This is the die. The point die. See that excess lead around there? That's a channel, or like a round trough for the extra lead, that little bit extra lead that I told you about. So it has a place to go. And it usually doesn't collect in there unless I don't have it polished well. This is polished well. It's probably got a ridge or something that's collecting that lead. Anyway, that's a little bit of the excess lead. Now, if that builds up enough, I'll be able to feel it in the press. Another thing I can do is just put a little bit of case lube in that ditch. And I'm going to use this. See this? This is the ditch. This lip here forms a cutting tool to cut the excess lead out when it gets squished in there. Okay, now this is just a thing with that's hollowed out, and it's got a stop, obviously. That's a 2mm pin. It goes in there, and this is able to adjust where the very end of it will be. I screw that in until I get the extraction pin right at the end of the bullet, where the bullet nose will be, and it doesn't go out farther, so that creates that stop. And also I have the automatic push button extraction. So that's how that works. Now, this has, because these bullets have a rebated base, or a heel, this die there, it's got the round part. I see there's a little lead in there too. I don't like that. Anyway, that'll squish that, and it squishes into here, and it pushes that in, and the excess lead goes around in that little ditch, and when these guys meet together, you notice it neats nice and tight. Now let's see if I can. No, there's not enough play in there to get a pop. But anyway, that guides it so that's it's centered, and the heel and the nose of the bullet are concentric. And this screw pushes the base, that brass middle, up and down, and that can regulate how deep that rebate is on the outside right there. That rebate you want, 10 thousandths of an inch, or wait, 100 thousandths of an inch. So, but it's a little flexible. You got between like 70 and 100, but 100's the best. So, that is basically how it works. They get squished in there, and where these two guys meet, these two surfaces meet, they form like an anvil type cutter to cut off that excess lead. Now, it's very difficult to get that cutter perfect because there can't be any chamfer on that inside of that, because that'll form a little bead, and it won't, that little bonnet won't fall off. And that's what they're doing now. When I have it just right, the bonnet literally falls off of there. But anyway, these are the products. These little bullets. Boy, now I gotta screw that in to get that out. These guys are the products of that system. Now that bullet, it's got a little bit of a ridge on there, right around where they meet. That's because that little anvil cutting system is not working quite right. Like I said, it's really hard to get, but that really doesn't matter because that gets taken care of when you crimp them. That's right where the crimp will go, and it'll squish that in, so there's no problem. Now these bullets are 0.2242 in diameter. And obviously if I polish the die some more, I can make them fatter. But I like them between 224 and 2248 diameter. You get them up to 225, they're a little too fat, and under 224, they're a little too small. Most bullets you buy are 2235. So mine are a little fatter. See, that's that little ridge that it forms. Now, and that's that hollow point. But this has been, I've been working on this system for quite some time. And different dies, I've made, I don't know, 10, 12 different dies so far. This is one of the older bullets. I used to make them with a bigger ridge around the bottom of that hollow base. And this is when I first started getting rid of that step. You know, I have some older ones yet here that I made with the step. The bullets you buy in a store have a step in them. And see that step where the bearing surface is a cylinder, and then the ogive is a step. And that they make them that way because their dies are three-piece. They have a cylinder, a base die, and a point-forming die. And where that point-forming die goes in, it's impossible to have an infinitely thin area. So it makes a step. And obviously I'm copying these. So when the first couple years that I made them, I made the step. And it occurred to me when I looked up one of the old, I got hold of a blueprint of a die system from 1915 for 22s. And it showed that three-piece die. And ballistically, I don't think it makes a lot of difference on 22s. But ballistically, they're better off without a step. You don't want a step on them. And So here, I'll show you one that is from the factory. This is a CCI factory before it gets loaded. Okay, this is what they look like before they're loaded. This is how they come out of their swaging dies. But what they do is they plate these and they run them through a ball mill, and it really softens all the edges. And it's a more crude looking bullet than mine, but it doesn't matter because the system in the factory is they'll put this in the case, and then the case will go through a machine that rolls it. It'll roll a crimp on it, and it'll roll a knurling in around it, and it'll roll that crimp, and right next to the crimp it'll roll cut it with a knife. You notice on a lot of bullets they have that little extra cut in them. They almost look like they're another piece. But that cut is what I call the snugging cut. A blade pushes in there to snug up the crimp. And they just can't. I guess they just invented that maybe 50 years ago. That snugging cut. But anyway, so these bullets don't have to be that. Their factory bullets don't have to be that close, because they run them through that machine that rolls them and crimps them and puts the knurling in there. Now, with the bullets that I make that are powder coated, knurling is completely unnecessary because of the powder coat. And that's the big advantage of my bullets. They do not have that step, and they don't need lube. That's got powder coat on there that's hard. I mean, it's probably, some of this stuff is cheap. But when I use the good powder coat, I bought some cheap stuff off of eBay that's not very good. But the good stuff is, it's got a hardness, Rockwell hardness in the 30s, I guess, which is, way, way harder than the lead. This is a harder one. You can't scratch that. That's hard. So that's the advantage of these guys. You can swage them to a very, very excellent final dimension without a step, and you have that hard lube on there. So that's how that works. Now let's see. I showed you the die, and I showed you how it works, and I showed you the bullets. I think that's it for now. I am going to show you how I crimp them, but that's going to be in another video. I also I made these guys, which I don't use them that much anymore, but I have these are steel 223 cases, and with modified Lee factory crimp dies, I can make the holes in them any size I want. So I made them with a hole that's 0.209, which is the size of the heel, and 0.225 for here to cut that little bad part off of there. And this one needs to be resized. It's got a little big on me, but I really don't need to, because that that little bad area around there, that little ring, gets shoved in when they're crimped, no problem. So that's the end of this one. That's the end of this video.